Alright, so today we're starting chapter 4, which is a little bit review and a little bit new. So our topic today is solving equations with x squared, and we have two questions. They are, what are rational numbers? That's review. And our second question is, how do I solve an equation with x squared? So how do I solve an equation with an x squared in it? And let's talk about rational numbers first. So we're going to do a lot of square roots today, and we'll need our calculator to help us. So to find the square root of a number in our calculator, the buttons we will press, I'll say that we're going to press the button that says second. It is blue in the top left corner. Then we're going to push the button that's on the left side that says x squared, because you can see right above that button is the square root symbol. Then once the square root symbol shows up on your screen, you will type in your number. And once you have your number typed in so that it looks like it says square root of 52 or whatever other number you're trying to find, you'll push enter. So those will be the buttons that we take. Now we get to practice them. So the square root of 121, we could do that in our calculator, but we should know in our head that's one of the perfect square roots. It's 11. And it says to find these square roots and round them to the nearest tenth if needed, but we don't need to round that. It's a whole number. The next one, square root of 7.5625. If we type that into our calculator, it turns out to be equal to 2.75, and then it stops. That's nice, but we need to round to a nearest tenth, and that means that we only want one decimal after the decimal point, one number after it. So we would round this one to 2.8 for our answer. The square root of 67 in our calculator, it pops out a very long number, 1.8185 ... That's not going to work. We are going to round that to the nearest tenth, so we would round it to 8.2, because the 8 behind the 1 bumps that up to an 8.2. Our next number, this negative square root of 3, negative square root of 9. We know the square root of 9 is 3, so really this is just negative 3. We don't need to round it. And we can type that in our calculator to get that answer. The next one, when we type in the calculator, it says error. If you type that in and push enter, it says error. And that's because we cannot have negatives inside the square root. So we would just say that this has no answer, that is not possible. Our last one is a fraction, and you can type this in your calculator. I'm going to write over here on the side what that would look like. I would push my square root button, and sometimes it pops up a parentheses when you do that. Then you would type in 256, and that fraction line means divide. So I would say divided by 81, and then it would give me the answer. But also, you can separate it into just do the top part and just do the bottom part, and then take the answer for both of them. So if I just do the top part, the answer is 16, and if I just do the bottom part, my answer is 9, so I get this fraction. And it's okay to leave our answers as fractions, so I'm going to leave it just like that, 16 on top of 9. So now that we've remembered a little bit about square roots, we need to remind ourselves what makes a number rational or irrational. I always think about irrational first. So irrational numbers are the ones that never stop and are random. So they're just some random number that goes on forever, random decimals. Rational numbers are anything else. So rational might be a whole number, rational might be a fraction, Rational might be a decimal that stops, so like 2.5 or 2.5, a decimal that stops or has a pattern. So if it is 0.13131313 with a pattern, it's rational. Random and never stop are the ones that are irrational. So now it's asking us the same numbers we got above. Were they rational or irrational? So we said this one was 11, a whole number, rational. This one was 2.75, a decimal that stopped, rational. This one was 8.185, ... went on forever and had no pattern, irrational. Negative square root of 9 is -3, a whole number, just a -1, that's okay, still rational. The square root of -25, that was an error. That didn't even have an answer. So we can't even say if it's rational or irrational. I'll just say no answer again. And our last one turned out to be a fraction, 16 on top and 9 on bottom. So that's a fraction is okay, still rational number. So we talked about these like the first week of school, and we are reviewing them again today. On the back, we're going to review a tiny bit of solving equations, which we just finished because we'll need it to do extra stuff today. So if we were going to solve this first equation, the only thing that I need to do is get rid of the -7. So I would add 7 on both sides. Then I would get no more 7s, just x equals 81, and I would be done. On the next equation, I need to get rid of the 19 on both sides. So I would do -19, -19, make it go away on the left, and it would say x equals 64, and be all done. What we want to see today is what happens if we change the x to an x squared. So now, if there's an x squared, I still see a 7 I need to get rid of, and I'm going to get rid of it first. So I'm going to add 7, but instead of saying x equals 81, it's going to say x squared equals 81. The way that we get rid of an x squared is the opposite of an x squared. And we haven't talked about this in a long time, but the opposite of a square is a square root. Why don't we put that down over here? The opposite of x squared is a square root. So if I want to get rid of a x square, I need to do the square root, and I always have to do things on both sides. So it would look like this with the square root symbol on both sides of the equation. That would make the square root and the square cancel out, and so they would go away, and I would only have an x left. But on this side, I still have the square root of 81. I could leave my answer like this, but I'll go ahead and simplify it and find the answer for the square root, x equals, and the square root of 81 is one of our perfect ones, so I know right away that it is just 9, and there's my answer. So we want to try it one more time on the next one. I still need to get rid of the 19 first, so I'll subtract 19 and make the 19s go away. Then it says x squared equals 64. But to get rid of the square, I'm going to do the opposite. I'm going to do a square root on both sides so that they will cancel out, and it will just say x equals square root of 64. But I know that one's another perfect one, so I'll say that it's x equals 8. So to kind of summarize, our box says, how do you solve an equation with an x squared in it? Well, I would say that the first thing we do is to add or subtract, was what we did, like normal, on both sides, just like we were used to. Add or subtract like normal on both sides. Then what we did, we do the square root on both sides, of course, always doing it on both sides, which was, or to do the opposite of x squared. So let me read that one more time. do the square root on both sides to do the opposite of x squared. We won't do much more complicated problems than the ones that we're seeing here and right now in this chapter. So these will probably be our only steps. We've got 2 more examples just to practice. So it also says for these, round our answers to the nearest tenth, like on the front if we need to, and to say if it's rational or irrational. So on both sides of this, the first thing I would do is add 42 to both sides, pretty normal. Make the 42s go away. So it says x squared equals 92. Now to make the x squared go away, I need to do the square root on both sides, which pops out just x, and then still a square root of 92. I'm going to go ahead and change this one to a whole number or a decimal if it needs to be. It turns out it is a decimal. It's 9.59 ... It goes on forever. So I already know that this is going to be irrational, so why don't I label it with an I? But it said to round it to the nearest tenth, so I'm going to round it to 9.6 because that 9 behind the 5 bumps it up to make it turn into 9.6. Got one more to try. On this one, I need to subtract 246 from both sides. Then I get x squared equals 54. And I need to get rid of the square with a square root on both sides. So only x is left, and x equals the square root of 54. Or if we turn it into a decimal, it's x equals 7.348 ... Again, that is random and going on forever, so it is irrational. And I should round it, so I'm going to round it to the nearest tenth. X is going to be 7.3 because that 4 behind the 3 is not big enough to bump it up. It has to be a 5 or bigger. So that would be my answer.